Welcome back, guys. In my first lecture today we're going to talk about subatomic particles. So they are like more than these, but for simplicity purpose and to focus on the MCAT content, we're just going to classify them, or we're going to just like make a list whatever we need. Okay, so the subatomic particles basically we usually find when you look at the atomic structure, we usually see them. Okay, they are electrons, okay, protons, and we have a neutrons, right? So as you can see here, the atomic structure of some kind of element. Okay, so as you can see here on the center here, this is the nucleus. Okay, and in the nucleus we have what do we have? We have a proton, okay, and we have a neutron, right? And the proton and the neutrons are sitting inside the nucleus, but the electrons are around the nucleus, as there are bonds of electrons in this atomic structure, right? In the first energy level, this one, okay, we have 1 and 2 electrons, and the second one we have 8, and the third one we have a 1 electron on it. Okay, so the electrons, they bear negative charge on them. Okay, the protons bear positive charge, but the neutron, they do not have charge, they are electrically neutral. Okay, and if you look at the mass of the proton is the relative mass of the proton is 1 AMU, which is called atomic mass unit, I, which is 1 AMU equals 1.66 times 10 to the power negative 27 kg. Okay, which is very small, right? But if you look the mass of the electron here, right, if you look here, which is 1 over 2000 less, right, less than that of the proton, that means which is very small, right, very negligible mass for the electrons. And if you look the neutrons, they do have mass, they have a higher mass than that of the proton and the electron. And if you look the relative ways, right, they have like around also 1 AMU, but slightly more than that of the protons. When you look at the element, right, we usually give a symbol like here, right, and X here is this X is the element, right, and here A and the G, we usually write the element, they symbolize the element like this way. A here is called mass number, the G here is called the atomic number. Mass number is the combination of protons and neutrons, okay, but the G is the number of protons. So what does that mean? So the number of protons gives the identity to the element. For example, carbon has a 6, right? Okay, nitrogen has 7 protons. So this is what it gives that element its identity, right? So let's go more in detail now. As you can see, right, there are some terms that I wrote here: isotopes, isobars, and isotones. Isotopes basically means they have the same G, that means same atomic number, but they have a different mass number. Okay, but different mass number. For example, if you look the hydrogen, there are 3 types of hydrogen we usually see. They have the same atomic number, right, and but they have different mass number. This is called protium. I don't know how to spell it. Protium, this is deuterium, and this is tritium, right? And the isobars is just opposite of it. They have the same mass number, but different atomic number. Okay, for example, if you look the argon and potassium, right? Okay, so the argon has number of protons 18, right? And there's a 40 for the mass number. And if you look the other one, the potassium, it has also 40 mass number, but its number of protons or the atomic number is what? 19. So this is an example of isobar. You can look for carbon and nitrogen also, where carbon has 6 is the atomic number, and the nitrogen has 7 atomic number, right? 7 is atomic number, and their number of protons and the neutrons, if you include them, that's going to be total to 14. Okay, so that's the another example of isobar. Isotones, on the other hand, what happens is they are different elements. Okay, but their the neutron number is same. Okay, neutron number is same, different elements but same neutron. For example, if you look the oxygen and nitrogen, right? Okay, oxygen has 8 atomic number and the mass number of 16, right? Nitrogen has atomic number of 7 and mass number of 15, right? Okay, then if you look the combination of proton and the neutron, there are proton of oxygen, there are 8 protons and there are 8 neutrons. Okay, but if you look the nitrogen, right, the number of proton is 7. Okay, and number of neutron is 8. If you combine them, 8 plus 8, which gives 16, right? But here 7 plus 8 gives 15. So the proton and the neutron, the combination has to give what the total, the mass number, right? So that's important. And the key terms we need to identify here is like some example for some terms are electron cells, where you can find electrons, and those cells often known as energy level. Sometimes electron has to go up to the higher energy level, and sometimes it has to fall down to the energy level. That's why they gain energy when they're going up, they lose energy when they're going down the energy level. Okay, the valence electrons are the electrons that we usually found on the outer electron cell. In this particular case, this is a valence electron, okay, and which is in the outer cell, and it usually participate in what? In formation of bond formation, right? As well as chemical reaction, and as well as sharing of or transferring of electrons, right? So all of that depends upon this valence electron. And the cation is if the atom, for example calcium, has a positive charge 2 plus, that is a cation which has a positive charge. For example magnesium, right? An anion, like for example chloride minus, which has a negative, is the charge, right? That's the one of the thing, like fluoride. Okay, so these are the examples of anion. So what we learned today, so what you need to know is electrons, protons and neutrons. Okay, and another thing you need to know is the value for E, which is 1.60 times 10 to the power negative 19 coulomb. If you're writing that for electron, we put negative charge. If you're writing that for proton, we put positive charge. And this is one of the very important thing you need to know. Okay, know it. Okay, and you need to know the electrons, protons and the neutrons are the subatomic particles. Electrons have a negative charge, protons has a positive charge, neutrons do not have charge. Mass is not that much of important, but what you need to know is electrons are or electrons have negligible mass. Okay, another thing you need to know here is this, the how we denote an element, mass number and the atomic number. You need to know the difference between isotope, isobars and isotons, and the key terms like electron cells, electron or the energy level, right? Valence electrons, cation and the anion. And remember that this is a very basic concept. They might not test you directly like what is the charge of the proton, okay, but you need to know to understand this solid information that we're going to present in future lecture. Okay, you need to know this basic concept. Okay, so thank you for watching. I'll see you in next lecture. Bye bye.